Hey guys, so this is 6.3 for algebra, or for principles of algebra, and as we go through here, we're going to rely on some skills that we built earlier in the year, and we're going to apply one new idea to that, and that's dealing with inequalities as opposed to equal signs. So if we look at a traditional equation, like say 2x plus 3 equals 9, okay, and we want to solve this. Because there's an equal sign, we are expecting there to be exactly one number that makes this equation true. In other words, there's only one number that if I use for x, that this left side will actually equal 9. I know from building the equation that the answer is 3. If I let x be 3, 2 times 3 is 6, and 6 plus 3 truly is 9. If I put any other number in where x is, I could put 7 there, or -1, or any other number besides 3, I will not get a true statement. So let's say I did a 1. 2 times 1 plus 3. I want to say that it equals 9, but 2 times 1 is 2. And 2 plus 3 is 5. And 5 is not equal to 9. Now, that is this idea that with an equal sign, we're looking for one solution. But sometimes we don't need to know the exact value. Maybe we just need to make sure that we stay under a budget. So when we're planning money on maybe for a family trip, we maybe say, okay, I've got $300 or $400 that we're going to spend while we're on this trip, maybe $1,000. Whatever that number is, we might say, I don't need to spend all of the money, but I definitely need to spend less than that amount of money. And so as we're planning and making budgets or making other predictions, sometimes we don't really want an equal sign. We want something less than, or maybe we want to be greater than something. And so we have these four symbols. We have the less than symbol, the less than equal to symbol, okay? What that means, with that bar underneath, so if I want to be less than 10, 9.9 works, but 10 doesn't, because 10 is not less than 10. But here with this equal to bar, the actual number is also acceptable. So I can be less than 10. 9.9 is less than or equal to 10, but 10 is also less than or equal to 10. So that gives me one more number that I'm allowed to use. I also have greater than, and I have greater than equal to. Okay, so those are my four symbols we're going to use today. Now the really cool thing about these symbols is they actually have a reason for existing the way that they are. This symbol, less than, it's actually the arrow head from an arrow that points to the left. You can see that with both of our less than symbols. And the greater than symbol, oh, excuse me, I think I'm going to have another one. There we go. And the greater than symbol is actually a symbol that points to the right. So if I say x is greater than 3, that means the number that I can use for x has to be on the right side of 3. So that kind of understanding can really help us understand why we're using certain numbers. Now the good news is the math that we use to solve these is essentially the same as the math we would use before. But instead of having one answer to an equation, we're going to have infinitely many answers. But we want to know what kind of numbers would be solutions to a problem. So we're going to do right here, the first part of your assignment is 3 through 11. We're going to look at 3 through 9, 3, 6, and 9. We'll do those three together. And then we'll jump down to the second part of your assignment and do a few of those. So let's take a look at question number 3. This is probably our simplest example. And it says 2x minus 3, sorry I wrote on top of it, is greater than 7. All right. Our goal is to still isolate the x. And the way we do that is by peeling off any addition and subtraction that we can do first and working our way back to the multiplication. So here I want to add 3. So I'm going to add 3. The reason I add 3 is because negative 3 plus 3 is 0, so that's a 0 pair. And I get 2x is still greater than 7 plus 3 is 10. Right here I want to go ahead and divide by 2. so that makes it a 1x. Okay, it was 2 times x, so the opposite of that's division. To divide the right, or divide the left, I have to divide the right. I still have that greater than symbol. 10 divided by 2 is 5. So here's my answer, is that x is greater than 5. But we also want to draw, or what's called graph, our solution on a number line. So here's a basic number line. I'm going to go ahead and put 0 somewhere on my number line. I need to put this number 5 on my number line. So I'm going to put the 5 right here. Okay. If we have a less than or a greater than symbol, we're going to use an open circle on the point. Because 5 is not greater than 5, I don't actually want to use that 5. But if it were greater than or less than and equal, we will use a filled in circle, okay, to say that that point is acceptable in our graph. So here, because I don't have that greater than bar, or less than, or equal to bar, sorry, don't have the equal to bar, I'm going to use an open circle on the 5, and now I need to shade either to the right or left, okay? And for me to know which way to go, I just have to read this. It says x is to the right of 5, which means all of the numbers over here on the right would be possible solutions to the equation. So if you grab one, let's say I pick the number 10. What's 2 times 10? Well, that's 20, and 20 minus 3 is 17. Is that greater than 7? The answer is yeah. So there's a whole bunch of numbers that will work for this. We just have to find the set, the whole set. And that's why we draw that graph, is to show, hey, there's a whole bunch of numbers. Let's look at question number 6. You guys will notice, if you look, 3 looks a lot like 4 and looks a lot like 5. 6 looks a lot like 7 and 8. 9 looks a lot like 10 and 11. So if you use each one as a pattern, I'm trying to give you that option. Show you one right here, and then you can carry that pattern across. We get 3 times w plus 12 is less than 0. Okay? A couple of different options for this. Generally, we just don't like having the parentheses here. So to simplify it, make it a little bit easier, I'm going to distribute the 3 and get 3w plus 36 is less than 0. And now I want to go through those same 2 steps. We remove any addition or subtraction. So because I have a plus 36, I'm going to minus 36 from both sides. And I get 3w is less than negative 36. And because this is 3 times w, we divide by 3, and we get w is less than negative 12. So there's my first answer. Second answer is the number line. So because negative 12 is pretty far to the left, I'm going to put 0 way over here. And I could write 12 marks. I don't really need to. I just need to label that there's negative 12. I'm going to change colors real quick. All right, this does not have that equal to bar, so I'm going to circle with an open circle. And this arrow says go to the left, right? That's an arrow to the left. So I'm going to shade everything over here and draw an arrow to say go left. Okay? And there's my answer to number 6. Let's look at number 9. We're going to clear that, and let's clear all this back over here. All right. So question number 9 has 4 minus 2m is greater than 7 minus 3m. All right. So here we have m on both sides. And that means we need to get the m's together before we really move forward. We always want to end up with a positive m if we can. And so what we want to do is look at which movement is going to produce a positive m. If I had to get rid of this negative 2m, I would add 2m. Adding 2m to a negative 3m on the other side produces a negative 1m. Not really what I want. I want a positive m. So I'm going to add 3m to both sides, and that'll give me 4. Negative 2 plus 3 is plus 1m, or just m. It's greater than. These cancel, so I get 7. Now all I have to do is get rid of the 4, and the 4 is added to the m, so I can just subtract 4 and get that m is greater than 3. There's my first answer. Second answer, there's 0, there's 3. There's no equal to bar, so it's an open circle. It points to the right, so I shade to the right. And I'm done. One caution. Okay, it's really important. If you ever end up in a situation like 11, a lot of you guys are going to want to just minus 6p because you just want to move everything over to one side. And that makes total sense. You get negative 16p is greater than negative 8. If the number next to your variable is negative, you're going to have to divide by that negative number. If this number is negative, when you divide by negative 16, the sign in the middle has to flip. Just like multiplying by a negative switches signs, division or multiplication by a negative is going to flip the sign. But it only happens when the number next to your variable is negative. So this becomes a less than symbol. You'll have to make that change along the way. The second part of your assignment is more of the same. There's no real distinction as we get into the second part. You're doing 17 through 31. We're going to cut that to 17 through 28 if we're doing this remotely. If we're in class, we'll talk about these 29 through 31 together. But let's just take a look at, say, number 23. It's as good as any. And then you guys, well, no, let's pick one with an equal to, greater than equal to. Let's do 24. So 24, we're almost done, guys. Bear with me. 4 plus 9y minus 3 greater than equal to 3 times 3y plus 2. If there's stuff we can combine just by combining on the same side, we always want to do that. I've got a 4 and a negative 3. Those combine to make 1. So I've got 9y plus 1 is greater than equal to, and any distribution that I can do gives me 9y plus 6. Okay, we want to try and get my y's, okay, on one side. They're identical though, which is a little weird, but I'm just going to move them to the same side. If I minus 9y from both sides, the cancellation that happens here will also happen here, and I'm left with 1 is greater than or equal to 6. Now you might not remember this, but there were problems when we were doing systems of equations and we were trying to solve them. There were some that ended up with a false statement, some that ended up with a true statement. So if all your variables cancel and you get true, that means there's infinitely many solutions because it's always true. If it's false, that means there's no solution. So ask ourselves this question: is 1 greater than or equal to 6? The answer is no. That's false. So there is no solution to number 24. You'll get maybe 1 or 2 of those in the whole problem set, but it's just the same thing. We move our y's to, or x's to one side, we move our numbers to the other, and we work from there. All right, good luck. You guys are going to have questions. Bring them to me. Let's deal with it. Good luck. We'll see you in class.